All right, everybody. Thank you all for joining us today. Our next speaker, Michael Rubin, is a data scientist and co-founder of ODAPES. ODAPES' mission is to democratize digital agriculture by giving all farmers, farming service providers, and local cooperatives access to a low-cost, cutting-edge, and customizable digital agricultural platform. The concept has already been successfully prototyped with clients across Latin America and developers from Venezuela, Brazil, Nigeria, Chile, creating affordable technology and local income opportunities. Michael is also part of the MIT Action Group on climate change, and he knows a lot about farming because he grew up on a small farm in Switzerland. Now, Michael lives in Sao Paulo, Brazil, and with his business partner, Nilo Arndt, they're taking Shiny into the field to impact smallholder farmers in South America. For anybody who isn't aware, Michael was a presenter last year at the 2022 Shiny conference. And so this is a little bit of a special presentation. We're bringing Michael on to give us a little bit of an update on the work he's doing and the impact he's creating. So Michael, without any further ado, welcome. And it's such a pleasure to have you again.
Thank you, Ian. Great to be back. Hello, everybody, wherever you are in the world. Thanks for the opportunity to speak, to update you on our business or our impact. So I want to just make a little wrap up of where we are. I made an extensive presentation of ODAPES of the technology last year. And I won't go into these kind of details this year, but I will show you a bit where we are and especially what we do, why we use Shiny. Let me just grab the laser. So why we use Shiny and present you a little use case. And this with the focus of a low-code extension we are building. I will explain why we're doing that. So first things first, why we live, why we are here, what we want to achieve. Our mission is truly to enable a fair, quality, and trustless data sharing across the food system. That's how we want to democratize the digital agriculture, because we see that there is a lot of skewness in the market, data which are not shared. Some farmers work with their data, food companies work with the other data, and they don't trust each other. And we really want to come in and solve this problem. I think this is the key to unlock a lot of potential we see. And you see up here, we start playing around a bit with Web3, which has nothing to do directly with Shiny. It's just a kind of an integration. And yeah, so to start a bit more in the broader context, what are we actually doing? I made here a simple graph, a simple chart, I want to say, with all the data science problems. So the numbers are more or less made up. I think it's more or less, we have $300 billion according to some studies, which is the net worth of all data science problems in the world. Of course, Google, Netflix, Meta, and so on, they take the biggest share. And they really start cutting the slices, which are very interesting economically. But everybody who knows something about data science knows that this tail goes on forever, right? So if we take all the data science problems, which are not among the top 100 economic problems together, we still get something in the ballpark of 2 to 10, maybe $20 billion cumulatively, of course. However, these are many different problems, and that's the point here. So in average, they are maybe worth 2 million, a million, maybe 5 millions. So these are small problems like pizza services or small farming problems. These are all businesses, but they have all different problems. So this is also where we sit with our problem, because we have not just one farming problem, we have hundreds or even thousands. And we cannot treat them all with the same big platform, with the same big data science logic or the same algorithm. And that's exactly why I use Shiny. So that's maybe the most important slide from my presentation. But I hope you stick with me. We started in 2020, like many companies, with an assumption that we need to build one app which supports tens of thousands of concurrent users, like building a new Facebook for farmers. So that was a wrong assumption. We learned that somewhere down the road, and then we say, okay, we have many different small needs or customer requirements. So what if we could build a web app tailored to the needs of each use case for a few $1,000s? And that's exactly what we're doing. We take Shiny, which is a great framework for this, and we go even a step further. So what we did, I wrote here key tech. What is the most important learnings from our side? We need to use, let the database being the workhorse of the system, because R is great, but it cannot do everything, especially not in the speed you need. Then just to connect with Emily, the last speaker, it's exactly what she said, modules. We use heavily modules. Sometimes it's even exaggerated. But for us, this is very important because we can then take them like, you build a car, you take a steering wheel, then you take the leather coaches, then you take the nice wheels and so on, and just start stitching together your personal app. And that's exactly what we do with Shiny modules. And finally, we also build, this is not yet 100% ready, but we are building an own low-code extension, because we learned also that one of the challenges is that even though Shiny is very intuitive and it's very easy to do great stuff, if you work every day with it, for newcomers, it's often a bit of a challenge. So we try to solve this and make it easier for the basic stuff, which we do anyway repetitively. The benefits, one client, one app, this is very clear. Also, our resources, they go now mostly into data science, where R is, of course, a great language, a great technology. And what we also do, this is the impact part, as we have low cost of development, we can actually afford to give away for small farmers, for the smallest farmers, the small cooperatives, the apps for free. They should use them. They should not pay for them. Well, what exactly is ODAPES doing? So here we have a very simple value chain. On the left-hand side, we have a farmer which is growing something. It can be somewhere in Africa, can be somewhere in South America or in the United States. And on the right-hand side, we have some food processor which is packing corn or wheat or baking bread or make cookies, whatever. There are hundreds of them, and there are millions of farmers. And the data, they don't travel. So we actually use Shiny on both ends as a very slim, very simple dashboard. It's not simple actually, but it's very thin to tell it in that way. And then our work is basically in the middle. So we are start using blockchain, Algorand blockchain, to create the trust. We also use a lot of techniques to take data from the field. They are mostly messy, they are incomplete, they are wrong. Sometimes sensors, IoT sensors don't work, and so on. So we correct this data, we clean them, we invent data where they are missing in a scientific way, not in a random way. And then we aggregate them, and then for the food companies, they get aggregated, of course, anonymized data, and say, okay, this year you should source wheat from different regions because you have a major risk in one specific spot where you used to buy last year. This is basically the service we're doing. And let's just have a quick look on our simplest, this is our styler. It's a part of the low-code extension. And this just takes our base app and creates an own brand, an own style, including logo. Let's just make sure I don't have the sound on. Oops. Yes, so it's a short video. So that's it. Yeah, so I already want to show our use case, just some word to this. It's before we did everything with CSS, with SCSS actually, and it was a lot of work always to adjust all these variables, and now we use BS variables, bootstrap variables to style everything, and it's much easier, much easier to change, especially to create is not that much gain of time, but if you want to change color or something like that, it's a huge difference. So a little use case. We have one client, which is called Metos Brazil. That's an IoT farming company down in Brazil. And they have a lot of customers which have, they have sensors, field sensor, which measure temperature or rainfall in the fields. And the problem is they have hundreds of sensors across a large area sometimes, and nobody has time to go into to hundreds of sensors readings and go through this every day. So they want to have maps, and they also people prefer PDF reports. They prefer to get it, right on their pockets, on their cell phones, and that's exactly what we do. The final product that starts on the right-hand side is a Markdown generated PDF, which you see has a header, has a map, which is we use SF to create this great package. I can recommend this, and they receive this every day or every week, depending a bit on the kind of sensors they have, by email, just like a newsletter. You see with the button, they can download the PDF report, which we generate. We use actually AWS Fargate to do this, because we generate a couple of hundred of these reports every day. So it's kind of paralleled out every morning. And then they also need to control these PDFs, or these reports, because not everybody want to have all the sensors, or some people only want to get them on weekdays, others only want to get them on Sundays, others want to have a logo up right where they have a partnership, for example, others want to have no logo, and so on and so forth. So just to show you, let me just switch over here. This is the app, and you see it's the same shiny app we have seen before with the map and the styler and all the stuff. Just it's much simplified here, and it has only 3 tabs. One is just to manage the whole report stuff. You can register new users. These are the users which obtain them. Then you can register also new partners, the logos especially, and then he can create the reports. So the reports, this is basically the content. If you have a map, or if you have a table which shows the rain, or if you have just a written summary which tells you, okay, there's so much rain in that part, and so on. And the agendas, this is actually scheduling in English. This is where they can, they can start a new scheduling and can say, okay, for this client, we want to get this type of report. We want to add Syngenta as a partner. We want to send it to these guys out, and then we want to schedule it on Mondays and Friday and Wednesdays. And we start right now until further notice. So that's basically, I won't confirm, otherwise they will get more reports which they don't want to pay for. And then we have the API connection inside, and we have, of course, the personal settings of the app. But what is the point here is, you see, this is really a simplified version, and this is done. I just made yesterday one of these apps for another client, and it takes me about a day to create the whole stuff, including all the parameterization, all the styling, everything. And then we have a working app, and that's basically our main, what we're doing. Okay, good. I'm almost done. I see I'm still good in time. What I want to say, I don't know where I got this quote here. I got it somewhere, but I like it. Those who are crazy enough to think they can change the world are those who do. I'm pretty much sure I will not be the one which changes the world, but you need to be a bit crazy and a bit ambitious to try at least. And many people trying to do good stuff with Shiny or with other technologies. Somebody will eventually change the world for the better. And if you think the same, I invite you to join ODAPES. We always have different projects. We We always work with the community. We also need some programs from every now and then. And if you, for example, are a university and you want to use this technology to run a project inside your research, please contact me. My data are here. And that's it. Thank you very much.
All right, Michael, thank you so much for this presentation. Before I get into the questions, I'm just going to quickly make the comment, really loving the mustache, and you just need to commit to shaving everything else. You've got the facial structure for it, Michael.
Thank you.
We didn't get a lot of comments in the chat, and encourage anybody, if you do have questions, to please add this. But the first question I had from myself is, we're talking a lot about how Shiny is basically doing everything you want. You're using Shiny in production in the real world. Are there ever any situations that you're finding where R or Shiny becomes the limitation and you're forced to use other technologies or other programming languages?
Yeah, there are. For example, I give you one example. We have another project where we basically use the same API which we integrate in this use case, but we need to import like 3,000. No, it's much more in data points. It's like 70,000 data points in total per day. A lot of calls, and this is just inefficient using R, and we can use Lambda or AWS Lambda, but then we need to use Python. This is one example, and of course, every now and then you need to use some JS, some HTML to add some functionalities. But I would say 90% is just fine with Shiny. And it's the details. Mostly it's the details, like either details of the UI or performance, which is an issue.
Okay, thank you for that. And I think you just said the magic word that leads me to my next question, because one of the things I was so fascinated about by your project is that you and Nilo are using AWS Lambda. And in the presentation last year, I mean, you clicked a button and it was generating these reports and doing all this, and the person was still using the app, or you were still using the app, sorry. Can you talk a little bit about like why you guys chose to go that route, the complexities you faced, and ultimately the value that it brought you guys?
Yeah, I actually have to admit that I'm not the infrastructure person. I cannot answer you the details or the question in detail, but where it all starts was with you guys. We once had a short cooperation, more consulting with Pedro, I guess.
Oh, fantastic.
Yeah, he gave us the very valuable tips that, guys, keep the Shiny layer as thin as possible. And that's how it came into being, that we developed an endpoint for AWS, and then everything what is inefficient we just throw there, and that's how it works. How exactly we use actually two AWS technologies: Fargate, where we do paralleling, and Lambda, where we have just a quick function. For example, the mapping is done, and also the API integration.
Thank you for elaborating on that, Michael. So we have a question from FM Kirchhoff. How do you go about maintaining rolling out changes in the one customer per one app approach? And maybe if I can expand upon that a little bit, because I imagine you built this amazing thing and you're giving it to all these people. Do you find situations where like one group loves it, one group doesn't, one group is asking for something new, and just how do you deal with that?
It's a great question, and it's the main challenge we have. In the beginning, it was a nightmare. Now it's just challenging, let's say it that way. But we have standard modules which do all the base works, and we don't change this from customer to customer. Where you see there are the tables, the tabs which manage all different items like weather stations or like the report entries or the users. We don't change these parts, but then we have additional modules which we create for customers. If they come with something completely new, we take like the skeleton of this module, which also will be very similar, just empty it and put then custom code. And this is then a module which we maintain only for this particular customs. Said that we don't run thousands of customs at this moment, right? We run a couple of dozens. So because it's a B2B business, it's not Facebook or something like that.
Okay, makes sense. One other question we got from Sivu, and we have a couple other questions along this line, but does the instrument/sensor data feed into an information management system? And just overall, how are you guys managing all this?
Absolutely, yes. That's one of the backbones we have. We call these variables. Variables are, you just assign to each value, like your temperature, your rain, your relative humidity, and what do you have? You have a unit, you have a max-min scale, you have critical values, and so on. And this is like a structure, and we feed every value which comes in from a sensor must necessarily feed into it. If you have an API, it's automatic, it's hard coded, and if you have farmers which, we have, maybe you saw the mobile device. It's like a scouter. It's not shiny, but they go with the cell phone out in the field. They take photos, they take readings, they take soil samples and put them in actually on spot. And then we need to associate this to a certain variables. This cannot be just numbers somewhere in the space. So we have developed an AI system which associates them. It makes it easier, right? You can guess what variable it is, and then he needs to confirm on this confirm. The user needs to do that. And then once they are in, they have actually a clear structure.
Okay, thanks for expanding on that, Michael. So we had another question that came in the chat from Paul. Did you have any issues parameterizing the maps into a PDF report? I found it tricky to automate the best dimensions when you don't know what the shape of the polygons will be.
Oh, yes. Yeah, that's exactly. I think you have to really. I don't know any. I don't remember any details by heart now, but you really need to work with these chunk options, whether you want to max out on width or on height, and then you have to set actually the maximum and minimum of the picture itself. It's not easy. So I think the question was that it fits then nicely on a page, right? That's it was. And I also have to tell that these reports, they are usually like templates. They are standardized. We don't create reports just on the fly. They have templates, and the template that knows, okay, here's a map, here's a table, here is a text summary or something like that.
Okay, great answer there, Michael. So, we talked about, this is an amazing example of Shiny being used in production in the real world. And we kind of talked a second ago about maybe there's a couple limitations, but, maybe if you could expand upon what are the main challenges that you're facing having chosen Shiny as your framework? And if possible, do you have any advice to anybody out there who might be trying to pursue the same sort of endeavor as you?
Yeah, the main point is this which I mentioned, this line which I mentioned somewhere in my slides. In most cases, you really don't need to build an app which supports 10,000 or 1 million users. It's maybe often a kind of a vanity assumption of some startup founders. I don't know, but this like laid the ground. And then I'm a data scientist, and I'm very close to R naturally, to R and Python. Anyway, this was great news for me to hear in 2019, I think it was, that, there is something where you can make an app out of R. That was a great news for me. And then it took its way. It was just a natural development. It fit into what we are doing.
Okay, great. So last year in the chat during your presentation, somebody had asked the questions along the lines of are you actually creating real impact, or are we just analyzing numbers? And I love it because I remember your response was, yeah, we're showing results. We're out in the wild. The results are evident. But maybe as a secondary question, how do you measure success for yourself, for you and Milo? Looking at these projects, and how do you look at the future and where you guys are going to grow?
Well, first of all, how we measure success. Most companies measure it in financial terms. We are not yet at this point that we would put the financial terms top priority. What we want at this moment is that people really use the app. We do something, we charge something in most cases, but then we want them to use, and we keep changing the app and improving the UI and make it more clear and better until they use it, because there's no point in selling something which nobody uses. This is maybe the first point. Then I don't remember what was the second part of the question.
Just more along the lines of how are you guys looking at this in the future, and where do you guys want to grow to?
Yeah, good, yeah, exactly. So what we see is we have these two front ends, right? The farmers and the food companies, and this is where we use Shiny, and we see our main business in the future in the middle. We wanna improve the data, because it's really the biggest problem, and this is independent of Shiny. The biggest problem in agriculture and food production is that data don't travel. Data are not shared. Everybody keeps them from itself, and this creates all sorts of risks and avoidable problems, avoidable losses. And we think that taking together Web3, taking together some AI techniques like the data-centric AI approach from Andrew Ng is very great in this. We can improve data, make good data product, which we use then just with Shiny as a front end, as a dashboard, right? So this is where we want to go.
Okay, thank you so much, Michael. So yeah, we're right at the end of our time. Once again, thank you so much for joining us, Michael. It's been fantastic to have made your acquaintance last year and follow your progress through this year. I think you're really one of the champions for the Shiny community out there, and I absolutely love this comment. Like those who are crazy enough to think they can change the world are the ones who actually do. So congratulations to you and Nilo on your success, Michael.